Today we're going to be discussing tension force. The goal of our lab was to measure how tension force changes across a swinging pendulum. Our coded model also represents our experiment of a swinging pendulum, as you will see. And some physics fundamentals for our lab was the momentum principle, understanding force body diagrams, and the velocity update formula and the position update formula. And here are the results of our lab. Our predicted result is that the tension will fluctuate throughout the course of the swing. And as you can see, these are our experimental data plotted onto a graph. And as you see, it is similar to a sine graph, and it fluctuates throughout. And above is our average tension, maximum tension, and minimum tension throughout the swing. And we do have some slight errors because there is some fluctuation within the graph, and this may be due to either human error collecting the data, or there may be an external force acting upon the system which we were not able to collect data on. Now, the experiment itself. We tied a rope to a water bottle and swung it in a pendulum fashion and took a video of it and put that in the tracker and collected the data. We then used that data in the graph you saw before. And then here is a video of that. Yeah. We then replicated that using GlowScript. As you can see, we first have the initial conditions of the experiment. We have the gravity, we have mass of the water bottle, and we have change in time, and we have total time. We also have the initial position, which is the initial condition. And then we have a while loop, which runs, and then we first have the current position, and then we update or find the velocity, which we then used for momentum, and we use momentum to find F net. We then find gravity, the force of gravity, and then we find or use F net and gravity to find tension. And then we update the velocity and update the position, and then repeat the steps. And as you can see, the key formulas are on the left as shown. And then here are the results of the computational data. As you can see, we have a similar graph to a sine graph again. And this is very close to our experimental data, as you'll see, and we'll show that later on. But here is the model that it showed. And here are the similarities between our graphs. As you can see, they both look very much like a sine graph and fluctuate throughout the time stamps. But our experimental data does fluctuate a slight bit. And this is due to, like we said before, human error or a force that we were not able to calculate. And here's some other factors of the lab. The system of our experiment is the water bottle and the rope, while the surroundings is the earth. Now, what if? What if the rope was shorter? How would this change the tension? It would change the tension because the water bottle would not be able to pick up enough momentum which would then increase centrifugal force, would put more strain on the rope, increasing the tension force. So a shorter rope means less tension. Now, what does it mean? Why is the tension force different across different positions of the swing? Again, this is due to centrifugal force. The momentum increases throughout the swing and decreases throughout the swing. The momentum is higher as it is going down the swing and almost right before it goes back up. This is where the tension is highest in the swing. Why we perform this experiment? We perform this so we can understand why the tension is different throughout the swing of a pendulum. And the results were that it fluctuates, but the highest tension is most likely at the bottom of the swing. And here's our average tension again, maximum tension, and our minimum tension throughout our swing. And the errors were due to human data collection and other forces that we were not able to collect data on. Thank you.